So now we're ready to start talking about trigonometry. Let's start section 7.2, right triangle trigonometry. We will do section 7.1 after 7.2. We're starting with 7.2. So let A denote one of the two acute angles of a right triangle. We are going to define the trigonometric functions of A. Sometimes we just say trig functions of A. And so I've drawn a right triangle here. Here's my 90-degree angle in the picture, and I'm going to denote one of these acute angles as A. So I'll pick this corner, and I'll follow a convention where I label the other acute angle as capital B. The 90-degree angle I'll label as capital C. And another convention we follow in a course like this is we label the sides of the triangle with small letters, lowercase letters. Across from capital A is side little a. Across from capital B is side little b. Across from capital C is side little c. And notice that A and B are the legs of this right triangle. C is the hypotenuse. So I think we're ready to define what we're going to call sine A. So we abbreviate it SINA, but that stands for SINE of A. And the sine of A we're going to define as a ratio of two sides of this triangle. We're going to take the opposite side to A and divide by the hypotenuse. Now the side that's opposite to A in this picture is the side of the right triangle that's not one of the two sides of the angle A. So B and C are sides of the angle A. Across from A, capital A, is this side little a. That's the opposite side to A, capital A. And so I can describe this numerator as little a over C is the hypotenuse of our right triangle, little c. So I can write a over little c. That's the sine of A. That's our first trig function. Our second trig function is called the cosine of A. There's the word cosine, which we abbreviate as just COS, capital A. And that's also a ratio of two sides. It's the adjacent side to A divided by the hypotenuse. Now, angle A has two sides to it, right? But one side of angle A is the hypotenuse. That's never the adjacent side. The adjacent side to A is always the other side. Or the adjacent side is always one of the two legs. It's the leg of the right triangle that forms one side of the angle A. So here, side B is the adjacent side to A. So that's actually B over, hypotenuse is C, B over C. And we have one more trig function we're going to define, TANA, which is the tangent of A. And that's the opposite side to A divided by the adjacent side to A. So let's see, our opposite side to A was little a, adjacent side's little b. So this is little a over little b. That's our third trig function. Sine A, cosine A, tangent A are each ratios or fractions that we get by dividing two sides of the right triangle. Now, we got to memorize this. We got to be able to keep this straight. And there's a very common mnemonic that we're going to use, and it involves just plucking off some of the first letters of these definitions. So I'm going to take S from sine, O from opposite, H hypotenuse. On the right here, I'll just write S. The sine equals O for opposite over H hypotenuse. Cosine C equals adjacent over hypotenuse. Cosine C equals A over H. And tangent equals opposite over adjacent. Tangent equals O over A. So these letters S, O, H, C, A, H, T, O, A, we usually just write in a row. S, O, H, C, A, H, T, O, A is what I call Sohcahtoa. And if you can remember Sohcahtoa, you should be able to keep straight the definition of sine A, cosine A, and tangent A. Okay? And this definition is actually our step one in our development of the trigonometric functions. We're going to take this a lot further in the weeks ahead. But we're also going to always hang on to this Sohcahtoa because we're going to find out it's helpful all the way through to the end. Okay, now there's something really important we got to note here. I'm going to start a second sheet. Now we had two acute angles in that right triangle. We also had a sine, we also had an angle B as an acute angle. So we can talk about sine B, cosine B, tangent B. Sine B would be the side, the opposite side to B divided by the hypotenuse. Now let's go back to our picture of the right triangle we're working with here. Angle B is up here, and so the role of opposite and adjacent are different for B than for A, because the sides of the angle B are A and C, the hypotenuse. Across from angle B is the opposite side to B, so the opposite side to B is actually the adjacent side to A, right? So from B's perspective, all right, little b here over C. Sine of capital B is little b over C. And let's see, cosine of B is going to be the adjacent side to B over the hypotenuse. So the hypotenuse is always the same for A or B. It's always going to be just C. But this adjacent opposite side business flips, right? The side that is adjacent to A is opposite to B. The side that is opposite to A is actually going to be, this is the adjacent side to the angle B. So cosine of B, capital B, is actually little a over little c. Tangent of B is the opposite side to B over the adjacent side to B. So we're still using Sohcahtoa, but the meaning of opposite and adjacent are different for angle B, right? So let's see, the opposite side to angle B is little b. The adjacent side is little a. So there are the trig functions defined for the angle B. So just think about how they come out different for A and B, and yet we still use Sohcahtoa to help us remember this. And one more observation before we quit this video. Call this observation. Whether a triangle is large or small, the trig functions, so I'll just write trig, short for trigonometric, the trig functions of a particular angle come out the same. This is all because we have similar triangles. Let's just draw a picture here. I'm going to draw a larger triangle, and I'm just going to pretend I know these angle measures. Pretend we know this is 25 degrees. Then the other acute angle would have to be 65, right? And I have a 90-degree angle in this corner. These add up to 180, so that's true. Now I'm going to draw a smaller one next to it with the same angle measures. So right angle here, 25 degrees here, 65 here. So these are similar right triangles. And I want to label the sides of the first, so I'm just going to label it little a, little b, little c. Now I can't use a, b, c again because the smaller one has different sides, so I'll use d, e, f. And so what we will call the sine of 65 degrees, this ratio, this number that we get, this fraction that we get, could be calculated from either one of these triangles. Now, let's see, Sohcahtoa, sine is opposite over hypotenuse. So for 65 degrees, in the first triangle it would be a over c, right? A over c. If I use the second triangle, though, it would actually be d over f. Now, d is smaller than a, f is smaller than c, but when I divide, when I take the ratio, the fractions come out equal. So these fractions must be equal since the triangles are similar. So that's just an important observation to make and think about at the very beginning of this, that we'll get so used to calling something the sine of a certain angle, whether the triangle is large or small, is because it will come out the same whether the right triangle is large or small. Okay, so that's this section, and next we'll move on to an exercise.